Using functions in Tableau is essential for being able to represent your data in the best possible way. Tableau luckily has a list of functions that you can directly apply to your uploaded data. Now, if you've used other functions such as SQL or Excel, these functions should already seem very familiar to you. Hi all, this is Upasana from Edureka, and in this module we are going to talk all about Tableau functions. Now, in Tableau, a user can use different types of built-in functions which can be applied to the following kinds of parameters. So before we begin, let's look at the different categories in which we are going to be using these Tableau functions. So we have your number functions, followed by string functions, then we have date functions, type conversion, aggregate functions, and finally we have logical functions. So without much ado, let's get straight into the module. So first of all, we have number functions. Now, number functions allow you to perform computations on your data values in the fields. So these functions can only be used with the fields that contain numerical values. Pretty obvious, right? On your screens right now, you can see all the number functions that I'm going to be covering in this segment. We will start with the absolute function or the ABS and close using the ZN functions, each of which I'm going to demonstrate to you using the Tableau Desktop. So let's get started with our first function. So the first function in the number functions category is ABS or the absolute function. On your leftmost column, you can see the name of the function. In the column in between, you can see its syntax, and on the right, you can see the description. So what your ABS does is it returns the absolute value of the number or the parameter that you put in the bracket. So if I give like a negative number in there, like a -5, then an absolute function is going to turn it into a 5 and return it back to you. It's kind of like the mod of a number. In the example that I've given, you can see we are trying to get the absolute value of budget variance. So suppose you had a field called budget variance. The ABS function will return the absolute value for all the numbers that are contained in the field. So let me go to my Tableau Desktop and I'm going to demonstrate how this works. So this is my Tableau Desktop and currently I'm using the 2019.1 version. This is the Show Me bar. If you want to know more about this interface and how to use Tableau Desktop, we already have a few videos, a few tutorials in our YouTube playlists. Please feel free to go ahead and check that out. This tutorial is specifically for functions in Tableau, so we are going to dive straight into that. So as you can see, I have already pulled in the data from the sample data set that is available in Tableau. It's called the Sample Superstore. Now this is only available in the desktop version and not in the public version. So make sure if you're trying to follow through with this tutorial, you are using the actual Tableau Desktop. So what I'm going to do is I'm going to navigate to Analysis and create a calculated field. This, what you see, is the calculation editor that opens. You're going to name it absolute, as we are going to try the absolute function right now. And I'll show you something simple in the beginning. It's as simple as this. You're going to go ahead and do ABS. And suppose I put in -5, which is the number. At the bottom, it shows my calculation is valid, which is a great thing about the calculation editor in Tableau. It prevents you from making further mistakes, helps you correct them immediately because at the bottom, it is going to prompt you whether your calculation is valid or not. Then I'm going to apply it and OK. So basically, if I bring this here, let me do the attribute. Yes. So it'll give me the absolute number. Instead of negative of 5, it's going to give me 5 because absolute is kind of like your modulus. It's going to give you the absolute value of the number that you have produced. So let's try it with a field that we have here. So let's go down. So we have this sales field here. So let me remove this and we can go make some changes. So I'm going to edit this field and instead of placing just the number, I'm going to put in sales. It's automatically going to appear to you. That is how smart this tool is. All right. So when I bring this here, it's going to automatically show a number here. Now what I'm going to do is I'm going to divide this by state. Alright, so we can see all the absolute values over here. Now what I'm going to do is I'm going to go to show me and put it into a map. So now we can easily go to each state and see the absolute sales in all of these states. We have South Dakota, North Dakota, Montana, and all the other states. As you can see, it shows us the absolute value of the sales in that particular state. All right. And as you can see on your right, it will show you the gradient of color, which basically means that the lighter the colors, the lighter blue there is, the lesser the sales are in that particular state, as opposed to the darker the color, as you can see in the state of California, or it may be New York, the sales are the maximum. No rocket science there. Let's go back to our presentation and look at our next function. So our next function is the arc cosine, or 𝐴cos. It basically returns the arc cosine of the given number. And the result will always be in radians. So if you give an arc cosine of -1, you're supposed to be getting something in lines of 3.1415926. As simple as that. So let's go back to our Tableau desktop and run this and see. Again, we're going to go to analysis and create a calculated field. You go and type 𝐴cos -1 and apply it. And like the absolute measure that we had discussed about the previous time, this also appears under measures in the data pane, just like your other fields, and you can use it in one or more visualizations. So I'm going to bring this here, and it shows 3.142, which is just the rounded off version of 3.14159, and that was all about arc cosine. Next, we have arc sine, which, as the name explains, returns the arc sine of the given number in radians. I'm quickly going to show that here again. And it gives you the answer 1.571. Next, we have the arc tangent, which is given in radians again. It is atan, which is the number function. I will go through this section pretty quickly, as these are not the functions which are used very regularly in Tableau, but they were kind enough to provide us with these functions, so we are going to use them. So I'm going to make an edit in this again. Just quickly going to go through. And you're supposed to be getting 1.565. Next, we have ceiling. Now, basically what it does is when you pass a decimal number to ceiling, it is going to round it off to the nearest integer of equal or greater value. So if I give it 3.26 or something, it's going to round it off to straight up 4. Now, these are available in a couple of data sources, like Microsoft Excel and text file and statistical files, but they are also not supported by a few popular sources such as Microsoft Access and Axion Vector or Amazon Aurora, so on and so forth. So here again, I'm going to go to create calculated field, and I'm going to name it ceiling, and then I'm going to put on 9.1265, just any number. So as you can see, the ceiling, what it did was it rounded off that number to 810, right? Let me try to. Okay. So that's all about ceiling. Next we have cos. Now cos, or cosine of an angle, it's pretty self-explanatory. Most of you, I'm sure, would have studied this in school. It basically returns the cosine of an angle if you give your angle in radians. So what I'm going to do again, so as you all might have studied in school, cos pi by 4 is 1 by root 2 or 0.707. So we're going to apply this. All right, so as you can see, it gives you 0.7071, which is 1 by root 2, which is again cos pi by 4. Next, you have cot or cotangent of an angle, same as cos that you're going to, I repeat, next you have cotangent or cot, and we are going to implement it the same way as we did cos. I don't think these trigonometric functions need a lot of explanation. We've all done these in school, so let's just get this over with. So again, I'm going to go with a pi by 4 because I'm lazy and I'm not going to think of any new angles. So as we all know, cot pi by 4 is 1. And as you can see, the value immediately changed to 1. The next function we have is degrees. Now what this does is it converts a given number in radians to degrees. And as you can see, pi by 4, as we all know, pi is 180. So your pi by 4 naturally is 45 degrees. And that's what it was supposed to do, and that's what it did. Moving on, we have div or division. So what it does is it's going to return you the quotient, where your integer 1 is basically your dividend and your integer 2 is your divisor. And it's going to give you the integer part of your quotient. So if I do 11 by 2, it's not going to give me a 5.5, but only a 5. As you can see, your quotient is 5. Next, you have the exponent or exp. Basically, it returns e raised to the power your given number. So basically, if we start with something simple, like we'll just put on a digit, say e raised to 2, it's straight up going to give you e raised to 2, which is 7.3. But you can also use these to put in fields and formulas, such as your growth rate into time, so on and so forth. Next, you have floor. Now, this is kind of the counterpart of the ceiling function, where it rounds a number to the nearest integer of the lesser value. So, like in ceiling, if I had to put in 3.1415, it would give me a 4. A floor, on the other hand, would give me a 3. So as you can see, I have used ceiling right here. So let's see, what had we done for ceiling? Okay, so I had put in the number 9.1265 for ceiling. Now let's try putting in the same number for floor. So I'm just going to make an edit in this. I'm going to put floor. Okay, apply and okay. And as you can see, immediately it went from 10 to 9. Our decimal has been rounded off to the lower number. Now again, like ceiling, it is not supported by Microsoft Access, your Action Vector, and your Amazon Aurora, Redshift, so on and so forth, but it is supported by your Microsoft Excel and text file and statistical files. There are many other files which support and also do not support ceiling and floor, but popular ones like Google Analytics and Google BigQuery support both of these functions. Next, we have hexbin. Now, basically what it does is it maps an x and y coordinate to the x coordinate of the nearest hexagonal bin. Now, these bins have side length 1, so the inputs may need to be scaled appropriately. Now, the hexbin x and the hexbin y are binning and plotting functions for hexagonal bins. Now, these bins are efficient and elegant options for visualization of data in the XY plane, such as your maps, or visualizations dealing with geographical data, your scatter plots, your hex plots. Now, because these bins are hexagonal, each bin is closely approximated to a circle, and hence it minimizes variation in the distance from the data point to the center of the bin. This makes clustering both accurate and more informative. Next, we have the natural logarithm of a number. Basically, you type ln and then your number, and it's going to return the natural logarithm. If your number is less than or equal to 0, it's going to return a null value. As we know that the natural log of 1 is 0, so that is what we get. That's the only one I remember from school, and that's the reason I put that in as my input. Now, something very similar is logarithm with a base, which we usually take as 10. So if the base value is omitted, you decide to not put in a base, it's by default going to use base 10. So we're going to put in, say, 100, and ideally we're supposed to get 2, and that is it. Log 100 base 10 is 2 because 10 raised to 2 is 100. Pretty simple. Next, we have max, which, as the name suggests, it returns the maximum of the two arguments which are passed. Now, the arguments must be of the same type, and this function returns null if either of the argument is null. So max can also be applied to a single field if it is used as an aggregate calculation, which I'm going to cover in the later segment of this particular session. So it can be as simple as, say, two numbers. So if I put it right here, show by attribute, 7 is larger a number than 4, so here you have 7. Or you could go ahead and put in two fields over there. Let's say profit and sales. And when we take the sum of it, now this I remember is the value of sales. Obviously, sales is going to be more than the profit. The sales field is going to have a higher number than the profit. So that's about it. Now the other half of this particular set is the minimum function, which is like the maximum function, but it returns the minimum of the two arguments of the same type. So if I just went ahead and edited this particular function, instead of max, let's name it min. And here again, instead of max, let's name it min. Let's put in the min function. I'm going to apply it, and this, I'm sure, is the profit field. As you can see, the number has changed. Next, we have pi. As the name might suggest, it is going to return the value of pi. .142, which is the rounded off value of pi. Next, we have power. So again, we're back at our Tableau desktop, and we're going to try and create a power field. So here, I'm going to just go for power and then our base, which let's take 10, and then the power, so we'll take that as 3. And ideally, our answer should be 1000. So if I drag it to rows, bring it to its attribute, we can see powers is equal to 1000. Next, we have radians, which basically does the opposite of degrees. It converts the number given in degrees to radians. So I'm going to go here again. So earlier we had converted pi by 4 into 45 degrees. So here I'm going to put 45 degrees, and let's hope we are getting pi by 4. So I'll take this rad calculation, put it here, and we get 0.7854, which is also pi by 4. You can do the math, use the calculator. Take this moment, pause this. You can go check. Then we have round. So basically what this does is it rounds a particular number that you put in to a specified number of digits, right? The decimals argument specifies how many decimal points of precision to include in the final result. Now, if that part you decide to not fill anything in, the number is rounded to the nearest integer, right? Now, before I move on to my Tableau server, some databases such as SQL Server allow specification of a negative length where -1 rounds to the tens place, -2 rounds to the hundreds place, and so on. This is not true for all the databases, of course, such as Excel and Access do not follow through with it. So with that, let's go to our Tableau desktop and see how this functions. So what I'm doing here is I'm going to round up every sales value to an integer. That's why I did not put anything in the decimals place. If I take a subcategory, all right, as you can see, everything has been rounded up to an integer. No matter what the sales in dollars is, there might be some decimals in there, but all of it has been turned into integers using the round. Next, we have sign, which returns the sign of a number. Now, the possible return values are -1 if the number is negative, and 0 if the number is a 0, and 1 if the number is positive. So I'm going to run this particular example, which I have given here. I'm going to run that itself on my Tableau desktop. So I'm going to be taking the average of the profit field, profit, and apply. Now, because the profit is positive in our given sample set, okay, this looks better. Now, what was I saying? Yes. Now, because our profit is positive in the given sample set, our answer turns up to be 1. If it were negative, it would have been a negative of 1. All right. After sign, we have sine, which is the trigonometric sign again. So it basically returns to you the sine of an angle. All we have to do is specify the angle in radians. So let's just So again, I'm going to take sine pi by 4, which is 1 by √2. So it comes up to be 0.707, same as your cosine. Then we have the square root of a number, which, as the name suggests, returns the square root of a number. So as we can see, the square root of 100 is 10. Next, we have the opposite of square root, which is the square of a number. Pretty self-explanatory. I'm just going to edit this, name it square. I'm going to do the simplest thing, and you might just think this is a lazy woman, which you're right, my friend. So I'm going to square 10 so we can get 100. And there you have it. It's 100. No big surprise there. With that, we have tan. Okay, so here we have the sign. What I'm going to do, I'm just going to edit this. Not going to create any extra sheet here. Just going to put tan and change this into tan. Tan pi by 4 is 1 for those of you who do not remember from school. And here we have the answer as 1. And with that, it brings me to the final of the number functions. We have Zn, which returns the expression if it is not null. Otherwise, it returns 0. Now, we basically use this function to use 0 values instead of null values. So this is how it works. I'm going to put in a field which I know does not have a 0 value. So I'm going to put in profit. So here I'm going to put in the average of profit. It's in the sum mode now. I'm just going to take the average. And I know for a fact it's not a non-zero value, and it's returned to me the average of profit, which is 28.66. With that, we come to the end of this segment. Let me head back to the presentation to start with the next module. The second segment is string functions. Basically, string functions allow you to manipulate string data. Now you can do all sorts of things with it, like pull out all the last names from your customers into a new field. One member might be, say, 𝐂𝐝𝐿, and then you can pull out all the customers with the surname Sinha and then put them in a new field using the string functions. So again, on your screens are all the string functions that I'm going to discuss, which is all the string functions that are available in Tableau. This by no way is an advanced tutorial. I'm just going to show you how each syntax works. So let's start with the first one. We have ASCII. As most of you know, there is an ASCII code for every character of the string, and what this function does is it returns that ASCII character. Now, as we all know, the string A has the ASCII code of 65, and that is what this returns. Next, we have char, which is kind of like the counterpart of ASCII. Here, it's going to return the character that is encoded by the ASCII code. Here, you have to put in the number, and it will return to you the character. And as you can see, it returns A. Next, we have contains, which basically returns true if a given string contains the specified substring. And as you see, it returns true. Next, we have ends with, which returns true if the given string ends with a certain substring. Next, you have find, which returns the index position of the certain substring that you're trying to search for in the string, or 0 if the substring isn't found. If the optional argument, which is start, as you can see at the end of this argument bracket, is added, then the function ignores any instances of the substring that appear before that index position start. The first character in the string is position 1. As you can see, it said that the substring 𝐸𝐾A that I was searching for starts from index number 5. Now let's see what happens if we put in our last argument. Let's put a 7. As you can see, because till the 6th index it was not asked to search, it returns a 0, which means it could not find the substring. Next, we have find nth, which basically returns the position of the nth occurrence of a substring within a specified string. So n is where the argument has occurred. So here in find nth, I've changed the word. I've put in learning here, and I'm going to search for when does n, the alphabet n, occur for the second time in the word learning. All right? So if I bring it to text, You see the answer is 7 because 𝐿EARNING, it's an 8-letter word where the second time N occurs is at the 7th position. Now, left returns the leftmost number of characters in the string. So you put in the string and then you put in the number till which you want your substring to be. Well, let's see, what do I like? I'm going to put it Matador and then 3. So it's going to print the leftmost 3 characters from the string. Then we have a pretty common one called length. If either of you have used Excel or Word or Access or any of these common databases and apps, you know what len does. It returns to you the length of the string. So what I'm going to do is, there you go, it returns the length of Matador, which is 7. Then you have a function called lower. Basically, you put in a string here and it will return you the string with all characters in lowercase. So I'm just going to randomly capitalize. Okay. So next we have ltrim. Now this basically returns the string without any spaces on the left. So if I try to ltrim space Matador space, it is going to remove the space at the left hand side of your string. And here you can see the space on the right is there, but the space on the left is gone. Then we have max, which returns the maximum of A and B, which must be both strings. Now this function is usually used to compare numbers, but it also works with strings. Basically what it does is it finds the value that is highest in the sort sequence defined by the database for the column. It returns null if either argument is null. So I'm going to put apples and bananas, just expression 1 and 2. You can put anything. And then it returns bananas because obviously more number of characters. Next we have mid, which returns the string starting at the index position start. So the first character in the string is position 1. If the optional argument length is added, then the returned string includes only that number of characters. So what I'm going to do is I'm going to use the word learning. And then I'm going to start with the second index number, which is supposed to be E. And then I'm going to give a length, say 5. So 5 characters. Then I'm going to apply it and OK. And as you can see, 5 characters starting from position 2. Next we have min, which is the counterpart of max. It basically reverses what we got in max. It's going to give you the string with the minimum number of characters. So we're going to do the same thing, apples and bananas. You can also put in a field in here and it'll give you the least value from that certain field. So as you go, apples having the minimum number of characters. Then we have right, which returns the rightmost number of characters that you have specified in your syntax. So if I put in learning and 4, it should ideally give me ning. And there we have it. Then we have the rtrim, which is kind of like the ltrim but from the right. So if I put in a string with spaces on the right, it's basically going to clear out the spaces. You're going to type the same word, spaces on the left and right both. And when we get it, you can see there is a space on the left, but not on the right, which is the opposite of ltrim, where we deleted the space in the left and we kept the space in the right. Next, you have space, which basically returns a string that is composed of the specified number of repeated spaces. So space 1 is going to give you 1 space, 2 is going to give you 2 spaces, so on and so forth. Then we have split. Now this is an interesting one. It returns the substring from a string using a delimiter character to divide the string into a sequence of tokens. Now the string is interpreted as an alternating sequence of delimiters and tokens. So let's see how this works. And I am going to C and D. Let's put these quotes on both sides. And then I'm going to put in what my delimiter is, which is the hyphen. Now I could have also used slash. The only thing you had to do is specify it in the delimiter part of the syntax. And then I'm going to put in the token number 2, which otherwise should have been my delimiter, this one, the hyphen. But because we've specified the delimiter, it's supposed to be returning a B. And as you can see, it returned B. Now the split and the custom split commands, which are kind of the same commands, are available for a few data types and they're not available for a few data types. So Tableau data extracts, Microsoft Excel, text file, PDF file, Salesforce, all of these support the split, and some data sources impose limits on splitting string. And there are these ones which support negative tokens, where there is a limit on the number of splits that is allowed per data source. Next, we have trim. Now, basically, trim is the combination of ltrim and rtrim. It is going to remove spaces from both left and right. So I'm going to again use, as you can see, space and Matador and another space. And as we can see, it has no spaces in the beginning or the end. And here we are at the final string function, which is upper, which returns the string with all characters in uppercase. So I'm going to go here and go with upper and randomly capitalize like I had done earlier. Let's see. And it returns to us Matador in all caps. So with that, we come to the end of string functions. The next segment is on date functions. Now, as the name suggests, the date functions allow you to manipulate dates in your data source, such as year, month, date, or time. So let's go to our first function. We have the date add. Now, the date add returns a specified date with the specified number interval added to a specified date part of that date. For example, if I put in month as the date part, 3 as the interval, and a date as the date, this expression would add 3 months to the date 15th of April 2004. So let's try this. Now this expression adds 3 months to the date. So we had 04 as in April for this date, but if I change this to month, it has July, which is May, June, July, addition of 3 different months. Next, we have date diff, which returns the difference between the two dates that you have input into this function. The start of the week parameter is the one which you use to specify which day is to be considered the first day of the week. It is optional, of course, but in a lot of countries, you consider Monday as the first day of the week, whereas in the other part of the world, you consider Sunday as the first day of the week. If this part is omitted, then the start of the week is determined by the data source. So let's see how that works. So as the date part, I am putting in week. Then I'm going to put in 2015, say 2015 October, and let's say 23rd. And then I am going to put 2015 and the same thing on the 11th month, November. I'm going to put in the start date as Sunday. All right, I think with that we're done. And we're going to change this. And it shows that the difference is 5 weeks. Next, we have date name, which returns the date part of the date as a string. And the start of the week parameter, again, like the previous function, you can use to specify which day is considered the first day of the week. It could be Sunday or Monday or Tuesday, depending on what you like. So if I put in the date part as year, and I put in the year and the starting date of the week, which in this case is not really necessary, it returns a string 2004, which is the name of the year that we had put in. Next we have date part, which kind of does the same thing as the date name, but it returns the date part of the date as an integer instead of a string. So if I made that edit here, it will return to me the same thing, but it is not a string, but an integer. Next, we have date trunc. Now, as a lot of you might have guessed, this basically truncates the specified date to the accuracy specified by the date part. So basically, this function returns a new date. For example, when you truncate a date that is in the middle of the month at the month level, this function will return the first day of the month. Again, this has the start of the week parameter, which you can use to specify which day is considered to be the first day of the week, so on and so forth. So I've put in this date and I've specified quarter. So it's supposed to truncate this part of the date completely and bring me to the beginning of the month. So when I bring this here, so as you can see, it has brought me to the beginning of the month July, and has truncated that part of the month from half the month, 15th of July, to the first part. Then we have a day, which returns the day of the given date as an integer. As you can see, it's 15. Next we have isDate. Now this returns true if a given string is a valid date. So if I put in February 30th, 2015, it returns false because there is no 30th in February. On the other hand, if I go ahead, edit it, and put in like a 28th of Feb, it returns true because 28th of Feb exists in every single year. Next, we have a makeDate, which returns a date value constructed from the specified year, month, and date. So if I make date with 2015, 3, and 15, I'm supposed to be getting 15th of March 2015. This is a slight derivative of the previous function. Now this is basically an extension of makeDateTime, and along with the date it adds the time as well. Next we have makeTime, which is exactly like makeDate except for it's for time. So it returns an hour, minute, and second of the time that you put in. Not going to spend much time here as they're all pretty similar in nature. Next we have max that we have used 2 times before, so I'm not going to demo this as well. Again, you will put in 2 dates and it is going to return the maximum of the 2 dates. Next we have min. Again, you're going to put in 2 dates and it's going to return to you the minimum of those 2 dates. Next we have month, which returns the month of the given date as an integer. So if I put in 2005-09-23 and close this, it gives me back 9, which was the month I'd put in. So this is an interesting one. This is called now. This returns the current date and time. Now, what it returns varies depending on the nature of the connection. So for a live unpublished connection, now returns the data source server time, and for a live published connection, now returns the data source server time. So I'm assuming that it is going to give you my system time. So just going to go with now. It gives you 2019. If I bring it down to the date, it's going to show 7th of May 2019, which is the day in which I'm recording this video. Another one like now is today, and basically what it does is it returns to you the current date. So instead of now, we're going to put in today, and it gives you today. Nice, isn't it? And finally, the last date function we are going to do is year. So basically, it returns the year of the given date as an integer. And if I bring this here, it gives me 2014, which is the year I had put in, and it's given it back to me as an integer. Next, we have type conversion functions. Now, why do you use these functions? Now, type conversion functions allow you to convert fields from one data type to another. So basically, you can convert numbers to strings, such as age values, so that your Tableau will not try to aggregate them. So let's move on to our first type conversion function. The first one is date. Now basically, this returns a date given a number, string, or date expression. So if I go in and put an order date, basically has given me a list of all the order dates that are there in the data set. Now I can obviously filter this by year. And bring it down to these many dates. Next we have date time, which is kind of like date, but it returns a date time given a number or string. Now, this I'm not going to show you the demo because it is very similar to the date function. Now we have date parse. Now what this does is it converts a string to a date time in the specified format. Letters that appear in the data and do not need to be parsed should be surrounded by single quotes. And for formats that do not have delimiters in between them, suppose hyphens and slashes and dots, verify that they are parsed as expected. So the format must be a constant string, not a field value. And this function returns null if the data does not match the format. So let's see how this works. So this is my format. And this is my date, 15 September and 2005. And this is exactly how it's going to show it to me. This is the same in the table. Next we have float. So basically, if I enter a float 3, it is supposed to give me 3.00. Next we have int or integer, which again, opposite of float, is going to cut down the decimal part of the number and give me only the integer part. And finally, we have a string expression. Basically, you're going to pass in an argument through it, and it's going to convert it into a string and give it back to you. So that's all about type conversion. Now let's go back here. For the string, I'm going to give you a demo. Rest all is kind of the same how we had done before and how you do it with other tools. So basically what I'm going to do is I'm going to edit this and str, and I'm going to put in the postal code. Now as we all know, postal code is in numbers. So as you can see, this is our postal code and it comes under dimensions. Why? Because it is currently number. As we can see, it's a whole number. Now what we're going to do So we're going to edit this str string and put in postal code and OK. Now, as you can see, the type conversion, which is basically the same thing as the postal code, has a string data type. The postal codes will remain the same, but their data type is going to change. That's what the string function does. And with that, we come to the end of type conversion functions. Let's move on to aggregate functions. There are a few more than the type functions here. So basically what aggregate functions let you do is that they allow you to summarize or change the granularity of your data. For example, if you want to know exactly how many orders your store had for a particular year, you can use the count_d function to summarize the exact number of orders your company had, and then break the visualization down by year. So there are a bunch of aggregation function out here, most of which we have already used as number functions before. And if we haven't used them as number functions before, while we have dragged it to our marks panel, most of you have seen how they work. So let's start with the first one. The first one is attribute. You might have seen through the course of this video how I have changed the default aggregate from sum to attribute many times over in this video itself. It basically returns the value of the expression like it has a single value for all the rows. So it is like one standard value. The null values hence are ignored. Next, as the name suggests, this is the average expression. It returns the average of all the values in the expression. Since I haven't used it before, I am going to show how this works. So suppose I bring in my sales here. As you can see, the default measure is sum. I can break it down to the average and it shows average sales. Nothing new, no rocket science. Next, we have correlation coefficient, which basically returns the Pearson's correlation coefficient for two expressions. Now, the Pearson correlation measures the linear relationship between two variables, and results range from -1 to +1, where 1 denotes an exact positive linear relationship, as when a positive change in one variable implies a positive change of the corresponding magnitude in the other. Now, 0 denotes no linear relationship between the variance, and negative of 1 is the exact negative of a relationship. Now, what I'm going to do is I'm going to use a table scoped level of the detail expression. So I'm going to go ahead and this is what it gives. It's between negative of 1 to positive of 1, and this is how far the relationship is linear. So you can say that the relationship between profit and sales is fairly linear because it's on the positive side. And with a level of detail expression, the correlation you can run all over the rows, and the view would show the correlation of each individual point in a scatter plot if you want to do that. Next, we have count, which returns the number of items in a group. Null values are obviously not counted. And then we have count_d, which returns the number of distinct items in a group, which basically means that if a certain item is there twice in a certain group, count_d is going to count it as one item. Then we have the covariance expression. This basically returns the sample covariance of two expressions. Covariance basically quantifies how two variables change together. A positive covariance indicates that the variables tend to move in the same direction, when a larger value of one of the variables tend to correspond to a larger value of the other variable on an average. Now, the sample covariance is the appropriate choice when data is random and it is being used to estimate the covariance for a larger population. Like we found out the correlation between sales and profit, we can also find out the covariation between sales and profit. Next, we have covariance of the population. It basically does the same thing as covariance, but this time of the entire population. Next, we have max, which we have tried thrice before. It returns the maximum expression across all records. We have median, which returns the median expression across all records. And then we have the min, which returns the minimum expression across the records. Next, we have percentile. What it does is it returns the percentile value from the given expression corresponding to the specified number. Now, the number must be between 0 and 1, obviously, and this function is available in Microsoft Excel and text file connections, Google Analytics or Salesforce, Cloudera Hive, Oracle 10, and the later data resources of Oracle, 𝐒𝐧𝐥𝐻 Solution 4.2 and the later versions, and Sybase. Next, we have standard deviation, which returns the statistical standard deviation of all values in the given expression based on a sample of population. Now, the same thing for the entire population and not the sample is the standard deviation of population. It basically returns the statistical standard deviation of all values in the given expression based on a biased population. Next, you have sum, which is also the default aggregate, which is allotted to all the measures and dimensions that you use. It returns the sum of all values in an expression, and of course it can be used only with numeric fields, and null values will be ignored. Then you have variance, which returns the statistical variance of all values in the given expression based on the sample of your population. And finally, we have the population variance, which gives the statistical variance of all the values based on an entire population and not just a sample. We're finally at our last segment, logical functions. Now, why should you be using logical functions? Now, this is basically used to calculate Boolean logic. If you don't know what that is, it basically means you give a certain condition and it tells you whether it's true or false. There is no other output than true or false. Now, most of these things we've already seen through the many functions that we have covered today, and the rest are very common logical functions if you are from any coding background. So what I'm going to do for this particular segment is that I'm going to go through all of these functions first and then go to my Tableau desktop to show you a tiny demo. So first of all, AND function. Now basically this performs a logical conjunction of the two functions. So basically it's the logical AND. If you look at the given example, it says if your market equals to Africa and the sum equals sales, both are greater than emerging threshold, then it should give the output well performing. Notice how both of these conditions have to be true for Tableau to give you an output of well performing. That is what logical AND does. For logical AND to work, both of the conditions need to be true. Next, you have case. If anybody of you are from the coding background, you can relate it with the switch case. It performs a number of logical tests and returns appropriate values. The case functions evaluates expressions, compares it to a sequence of values, and returns a result. When a value that matches the expression is encountered, case returns the corresponding return value. If no match is found, then the default return expression is used, and if there is no default return and no values match, then null is returned. Case is often easier to use than if, else, and statements like that. Typically, if you use an if function to perform a sequence of arbitrary tests, you can use a case function to search for a match to an expression. But a case function can always be rewritten as an if function, although the case function will generally be more concise. So many times you can use a group to get the same results as a complicated case function. We'll learn more about if in the later parts of this logical functions segment. Next, we have else. Now, this is the counterpart of if. So, if something, then a condition has to be either fulfilled or not fulfilled. It will give you an answer. Else, it will give you another answer. It's as simple as that. It tests a series of expressions, returning the then value for the first true expression. Then you have else if. If you have a number of if statements before your default else, then you use else if. It tests a series of expressions, returning the then value for the first true expression again. Then you have end, which as the name suggests, it marks the end of an expression. Then you have if, as we have already discussed. If basically tests an expression and then returns a corresponding value. Then we have if null, which returns the expression 1, if not null, otherwise returns expression 2. It is basically like a regular if function, except for it just checks for one condition, if the expression you've put in is null or not. Next is if, which checks whether a condition is met and returns one value if true, another value if false. It's basically like a test case, and an optional third value or null if unknown. Next we have isDate, which returns true if a given string is a valid date. It's no big deal. Then we have isNull, which returns true if the expression does not contain valid data, which is if your expression is null. Then we have max, which we have discussed many times before. It returns a maximum of all the records or maximum of 2 expressions for each record. Then we have minimum, which does just the opposite. It returns the minimum of all records or the minimum of 2 records. Then you have the logical not, which performs logical negation on an expression. So basically, if the field you have put in does not fulfill the condition, then it gives you the corresponding result. Then you have the logical or, which basically means that if you have put in 2 conditions, either or of them have to be true, then it will give you a result. Then we have then, which we have discussed before. If a certain field fulfills a condition, the corresponding then part is then fulfilled. Now here we have a when function, which finds the first value that matches the expression and returns the corresponding return. It's kind of like if and then case, except for there is no if. Then you have zn, which returns your expression if it is not 0 or null. We have discussed this before. Now let's go to our Tableau desktop and create a logical calculation to see how you can use this. So now again, come back to our Tableau desktop one last time for this session. So again, I am from the data pane, drag state to the rows shelf. As you can see, a table like this should ideally appear. Then I am going to take category, place it at the rows as well. This is nice. I'm going to analysis, as I've done many times before in this session. Create calculated field. Here I'm going to name this KPI, which is Key Performance Index. Basically shows you how your company is doing internally and externally. Internally as in different departments and externally as in the market. I'm going to do a simple sum profit. We can see this here. Now this calculation quickly checks if a member is greater than 0. If so, it will return true. If not, it will return false. It's kind of like the if and then statement. So when finished, you can go ahead and click OK. As you can see, this new calculated field appears under the measures in the data pane. Just like your other fields, you can use it on this visualization. So I'm going to drag this to the color on the marks card. And I'm going to turn this whole thing into... So I'm going to take the sales and put it in the columns. You can now see which categories are losing money in the states. So all these orange ones are the ones in profit and the blue ones are the ones at loss. And that's the simplest use of the logical functions. You can use this for way more because Tableau is capable of not just pretty graphs, but a good drill down of data. With that, I am going to close this session. Thank you and have a great day.